Much of your guys' time. Okay, so Euler's identity, which you pronounce Euler, is a thing about complex numbers that I can't demonstrate to you really easily. So I'm going to write this down, and then we can have the longer version. So the short version is e to the I theta equals cosine theta plus I sine theta. Okay, and then we also need to know something about this, which is that I is the square root of -1.
But it's the imaginary number.
Yeah, and I don't like this phrasing.
Imaginary number.
Yeah, I would prefer that you think about this as
Z.
complex number,
Fair enough.
not imaginary, because imaginary says that you don't need this thing in your life.
I agree with that.
And if you do a bunch of engineering, you need a bunch of this thing. So specifically, if you're doing lots of electrical stuff, you need a ton of this. If you're doing lots of like spring calibration stuff, you need a bunch of this.
Cool.
Cool. So this thing does appear in your life. It appears in your life every time you drive over a speed bump, and the car goes like this. Right? There's a complex number in there somewhere, because there's a sine wave in there somewhere. Cool. If you want to see where that comes from, you can watch the videos from the differential equations class where I'm talking about springs.
All right.
Cool.
Cool.
I don't have the tool to prove this to you, but let me suggest to you an idea. Okay?
Prepared.
In Calc 2, you'll make this.
E to the x.
You'll find out that e to the x is 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4th over 4 factorial, and so on. You can trust me that that'll happen. Cool?
Yeah.
That's actually a very, not particularly easy thing to know. Also, please note, this is not a polynomial, even though it looks like one. Why is this not a polynomial, even though it looks like one?
Well, this code keeps going.
Yeah, polynomials stop somewhere, right? Like, polynomials have they get to x to the 10th, and then there aren't any more x's with higher powers, right?
Such as in the case.
So this is a polynomial of infinite degree. It's a weird thing, but there's a good reason to make this. In fact, this is how your calculator does everything.
It just goes until it can't go anymore.
Yeah, basically it goes until it gives up on precision, and then it stops.
Makes sense. That's pretty cool.
Then another thing you learn is that cosine of x is 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial.
What kind of 8 is that?
You fell apart. Leave him alone. Gosh, be nice to him. All right, so that looks like which parts of this?
Well, it looks like the even parts of it.
It looks like the even parts, but
But minus.
half of them are negative, which is weird, right? And then at that point, right, like you discover this first because e's like your favorite function in calculus land. So you did this one first, and then you were like, but what about trig functions? Those will also be easy. So you did cosine and you got this, and you're like, what? Wait a second. This looks like it matches that, kind of.
Yeah.
And then you're like, okay, well, if I'm missing the odd parts, where do the odd parts probably come from?
Sine.
Sine, right? So you're like, okay, so I'll do this for sine. So you start this for sine, and you get x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and kind of so on, right?
There's no 1.
Yeah, there's no 1.
Well, the 1 is already included in cosine.
Yeah, and then you notice, like, hey, dude, if I took that one and this one and added them together,
We get the other one.
I would, like,
Get 1
almost get
plus
e to the x.
minus x squared over 2.
You guys see that? Like you don't actually get e to the x, you get
Yes.
almost e to the x, because it goes plus, plus, minus, minus, plus, plus, minus, minus, plus, plus, minus, minus. And you're like, dude, what the heck? And then you remember sometime back in the day somebody told you about the square root of -1. And you try
Oh, man.
e to the I x and plug it into this and this and this.
That's so.
And then you
Cool.
notice something cool,
That is so cool.
which is this. Okay?
That makes so much sense now.
So you have to have this part before we can talk about Tomopoulos. But you want this part. So the too long didn't read version is put this part in your brain. Cool?